Hello everyone, welcome to this video. This video is about our final project for ELEC 327. Our project is a smart watering system which can help people to take care of watering their plants and save a lot of time. Our expectation for this system is that it will constantly monitor the moisture in the soil to determine the time for watering, display the measured moisture on 4-digit LED display, and trigger the buzzer when the water gate is open to alert people of potentially splashed water. We implement this system by connect our designed PCB to other necessary components via the groove-based booster pack. On the PCB board, we have a MSP430 G2553 and a buzzer. We also have a battery case so that this system can work independently without other power supplies. In order to determine when the system gonna do the watering, we have moisture sensor in our system. The moisture sensor has an output pin that will generate analog signals. To get the analog signals is sent to us, we think that ADC10 will be a great helper for us, because we remember that in both Lab 5 and Lab 6, we use ADC10 to get the readings from the temperature sensor, which also output analog signals. Since ADC10 is only available at pin 1.3, it will be our only choice for the output pin of the moisture sensor. And then we have a 4-digit LED display to directly show the moisture level, the TM1637 4-digit LED display. This LED display requires 2 digital input pins. One is clock and the other is DIO. We decided to connect the clock pin on 4-digit display to pin 2.6, which is regulated by timer TA0.1. As for the DIO, we connected to pin 2.7. Finally, it is the motor. This motor is controlled by the moisture sensor. According to the moisture readings, the motor will turn on or close the water gate. And according to the datasheet of the motor, it is controlled by PWM signals. We have already allocated TA0.1 for the 4-digit display. Therefore, for the motor, we decided to allocate the motor to TA1.2, because we also noticed that on the PCB we have designed, where we have already allocated TA1.1 for the piezo buzzer at pin 2.1, because the buzzer needs to use the PWM to generate sounds. So we connect the input pin of the motor to pin 2.5. These are all the parts that we have for this system. And this system will constantly detect the moisture level of the environment around it, for example the soil or the plant. If the moisture reading is above the open gate threshold, it means that the environment has good enough moisture level and thus has no need for watering. The motor will keep the water gate closed. Once the moisture reading goes below the open gate threshold, the moisture will open the water gate and trigger the buzzer at the same time to alert people. In the process of the watering, the moisture sensor is still gonna measure the surrounding humidity. The water gate will not be closed until the moisture reading of the moisture sensor reaches above the closed gate threshold, which means that the plant now has enough water. In this way, the system can make sure that the plant always has enough moisture. And then, let's take a look at our live demo.
So here is our simple live demo. You can see here the moisture level is displaying on the 4-digit LED display. And if I use the wet paper towel, touch the moisture sensor, the motor should stop and the gate is closed. And if I expose the sensor in the air, since the air is dry, the motor should turn on and the gate is open. But there is a certain latency between the sensor and the motor, so it costs some time for the motor to turn on or turn off. And we may fix this problem in the future, and we will improve our system. Thank you for watching this video.